This is the video for Mod 7 Lesson 1, Angle Relationships. The goal of this lesson is going to be to identify and apply properties of vertical angles, identify and apply properties of supplementary angles, and identify and apply properties of complementary angles. So the big goal we're going to be looking at is focusing at angle pairs and relationships and seeing how we can use that to set up equations and solve for unknown angles. The first definition we're going to use and apply in this section is our vertical angles. So vertical angles are angles that are formed by two lines that are intersecting. This is something that you learned back in Math 1. If we have two lines that intersect, the angles that are across from each other, for example, like angle 1 and angle 2, those are considered vertical angles because they're formed by two intersecting lines. So if we have two angles that are vertical, we can actually assume that they are congruent. So vertical angles is one of the few things that we're allowed to assume from a diagram because we're allowed to assume lines where they intersect. So angles formed by intersecting lines that are across from each other are going to be vertical, and I would be able to say angle 1 and 2 are congruent or the same measurement. Same thing with angle 3 and angle 4. Angle 3 and angle 4 are vertical angles, so I know that they're going to be the same measurement. All right, so really if we know one of those angle pairs, we actually know all the angles in the diagram. So for example, if I knew that this was 50 degrees, I actually, like for angle 1, I would know that angle 2 is also 50 degrees. And then if I wanted to find the remaining angle, which we'll see in a moment, I can subtract from 180, right? So we are eventually going to be able to find all of our angles in the diagram. For the first examples we see here, we're just applying properties of vertical angles. So they don't have to tell you that they're vertical for us to be able to assume from the diagram that they're intersecting these two lines. And so from this diagram right away, I can go ahead and mark my angles as congruent. So 5x and 3x plus 60, those angles are going to be the same measurement. So I know that those expressions have to represent the same value. So if I have vertical angles and I know they're congruent or equal, when you have that they're vertical, we can just set the expressions equal to each other. So we end up with 5x equals 3x plus 60. And then if we go ahead and solve, we would get our answer for x equals 30. Now, if the question was asking for what the measure of the angle is, the angle itself is not 30 degrees. This is just the value of x. So if I wanted to find my value for the angle or the actual measurement, I'd have to substitute it back in. I could substitute it into either expression. The 5x is probably going to be the easier one, but both should give me the same answer. And I would get this to be 150 degrees. So each of these angles is actually 150. For the second example, it's essentially the same type of problem. So I can assume the lines intersect. They're forming these vertical angles. Since those angles are the same, I can set their expressions, the expressions equal to each other. And the reason I'm able to do that is because the angles are the same measurement. So when we go ahead and solve, again, solving just a linear equation, we're going to subtract x. Add 40 and divide. So this one we also get an answer of 30, but again, that's the value for x. That doesn't necessarily mean that's the angle measurement. So if I was to take this and substitute it back in to find the actual angle measurement, we would have x plus 30 x plus 20, if I put in the 30, so 30 plus 20, and this actually ends up being 50 degrees, right? So this right here is a 50 degree angle. The next angle relationships we're going to talk about are supplementary and complementary angles. Again, this is a review that you saw from Math 1, but again, we're just kind of adding some stuff to it. So the first definition we have here are supplementary angles. So if angles have a sum of 180 degrees, we consider them supplementary. We also know that if they form a straight angle, right? So this is an example of like a straight angle, right? It almost looks like a straight line, but again, it's an angle. We call that a linear pair, right? So again, that's something you maybe remember back from Math 1. The idea is that if I have two angles, and in this case, like in the diagram, they're forming a straight angle, so they're actually forming 180 degrees. Angle 3 and 4 are what we call supplementary, so they add up to 180. So the statement I might write here is that the measure of angle 3 plus the measure of angle 4 is 180. Right? So anytime you have two angles that look like they're forming a straight line, we can assume that they're supplementary. They're adding up to 180. Same idea with complementary. The only thing is it has a sum of 90 instead of 180. So if two angles are complementary, they have a sum of 90 degrees. And also, we a lot of times see that if two angles are forming a right angle, and a right angle has to be marked, right? We can't ever assume it's right unless they tell us it's right or marked with a little box. Then those are also complementary. So again, complementary means adds up to 90, supplementary adds up to 180. So if I have two angles that are forming a right angle, that would mean the measure of angle 1 plus the measure of angle 2 is equaling 90 degrees. So this whole, that whole sum would be 90 degrees or a right angle. So for these two examples, again, the first thing we have to do is identify the angle relationship, right? So we can't just assume we always add up to 180, add up to 90, set them equal. We have to look at the diagram, mark the diagram, and identify what the relationship is. So if I look at this, I see I have x minus 22, 135. If I look at these two angles, they're not vertical angles, right? Because the vertical angle would be down here. What we can see though is that they do, when we put them together, they do form this straight angle, right? So if I look at that, that actually is going to be a linear pair. So I know that this adds up to 180 degrees. So probably the most challenging part is reading the diagram, seeing the relationship, and making the correct equation for that. So I know that these two angles together, although they're not the same, when I put them together, I get 180 degrees. So then it just turns into an algebra problem that we're used to solving. I'm going to combine like terms. This is 113. And then just subtracting. This is one of a whole bunch of different ways you can do this problem. But you should either way get the answer to be 67. So our value for x is actually 67. If I wanted the angle, I could plug it back in, but the question was just asking you to solve for x. Same idea for example 2. So first we have to identify the relationship here. So I see that these two angles are forming a right angle. So when I put them together, I get 90 degrees. And then we're just gonna, then I know that even though they're not equal, I can't assume they're both 45 or set them equal. I know when I put them together, they're gonna add up to 90. So we have here 56 plus 3x plus 7 is equal to 90. If we go ahead and combine like terms and solve, we get 63 plus 3x equals 90, and then we would just solve for x. And so our answer for x, our missing value is 9. That's not saying that's 9 degrees. If I wanted the angle, I'd plug it back in or substitute it back in, but the question was just asking for x. If you have questions, make sure you are trying the You Try problems, and then asking for help during class, signing up for T-Bolt time, or getting help in the center.